Welcome to the second edition of the networking model series. In the last series, we spoke about the various we spoke about networking models and the OSI model, the various layers of the OSI model, and the various types of data or information that you find at each layer of the OSI model. So, and we said we are going to use our understanding to explain the various functions which you can find at each layer of the OSI model. So, in our series today, we are going to be talking about the various functions that you find at the various layers of the OSI model, using the same understanding of the data passing from the sender, information passing from the sender to the receiver, uh, and it goes from top to bottom and from down to top on the receiver side. So the very first layer, if a sender is sending uh, data, let's say I send something like go to bed to the receiver. So this is my datagram. So what happens typically is this datagram passes to the application layer. So this is the very first layer where the user tends to interact with the network, because for the user to send the data, probably it's going to send from his mobile phone, or it's going to send using an email, or it's going to send using pager during the days of pager. It means that the sender needs to interact with the network at a point in time. So that interface where you interact with the network, either you're browsing the net or you're sending an email or you're using an application, so you must interact with the network. So that layer that allows the user to interact with the network is the application layer. That on the sender side. So I open my email. That email application is sitting at the application layer, and I need to interact with my email, by typing my email. So that is what the application layer does. It allows the user to interact with the network. But that is not just what the application layer does. The application layer also confirms that the receiver, there is enough resources, that the receiver is available, and there is enough resources on the receiver side to process the information. So what happens is, if I send an email to say I'm sending an email to ABC, ABC at EFG, and I just do at EFG. I did not put .com, for example. Let's say I did not put .com. So what happens is, the application layer is going to is firstly going to check, does this receiver exist? If it exists, can it process email, for example? Is there an email receiver? So that's one of the things that the application layer does. It confirms the availability of the communication partner, and also confirms if the communication partner has enough resources to process the communication. So this is where things like email validation comes into play. So, and this is what the application layer does. So then the data goes to the presentation layer. Now, the presentation layer is serving as a gateway, in the sense that it collects the data and it formats the data. So this is where data formatting comes into play. It formats the data into the format that other lower layers of the OSI model understand. So data formatting happens here. If you have to encrypt the data, this is where it happens. Encryption, decryption, this is where it happens, encryption on the sender side. So the presentation layer formats the data. It does things like converting the data into the format that other lower layers could understand. Don't forget that all of this, the data is still residing within the domain of the sender. No communication session has been established, and that is what happens at the session layer. So at the session layer establishes communication session with the session layer of the receiver. We want to send you data. So they set up a kind of communication session between the sender and the receiver. That's what the session layer does. So, and once the receiver is also available, then it agrees to set up the session based on certain parameters, the session is going to be established. This is the beginning of the communication between the sender and the receiver. Before it gets to the session layer, the whole of the communication is happening within the domain of the sender alone, the sending party alone. So the session layer is responsible for establishing communication session on the sending side. Don't forget that we are looking at the functions of each layer of the OSI from the sender side. We are also going to look at it from the receiver side, like I said in my last video. Then we are going to combine both together to form an holistic function of each layer of the OSI. So these three layers are the upper layers of the OSI model. And don't forget, we said in our last video that what happened at the upper layer is what is processed at the upper layer is the data itself, the datagram itself. Now the session layer needs to pass the data to the transport layer. So the data goes to the transport layer. So what happens at the transport layer? The first thing that happens at the transport layer is the data is converted into segments, like we have said in our last video. So this is where the data is converted into a segment. But much more than that, there are three tasks that you find at the transport layer. The first one flow control, sequencing, buffering, and congestion avoidance. So that's flow control. Functions for the transport layer. So at the transport layer, I've cleared the canvas so that we can have enough space to work. So the data is coming from the session layer and it passes down to the transport layer. So at the transport layer, you find three major functions. So you find acknowledgement, or we say handshake. Then you find sequencing. Then there is flow control. Let me explain each of these functions one by one. So don't forget that we are looking at the scenario of sending party and a receiving party. So for acknowledgements, there is a way for the sender to know that the receiver is still available. You know, the session is established at the session layer. So, but the sender also still needs to know that the receiver is still available. So what happens is the sender sends a packet, an acknowledgement segment to the receiver to say, are you there? So this is like saying, are you there? Then the receiver is going to respond by saying that, yes, I am here. It's going to send an acknowledgement sync. And then the sender is now going to initiate the communication proper. So this is called the three-way handshake of TCP/IP. I'll go into the details of this later. But just know that acknowledgement is a way to know that the receiving party actually got the packet. Because if the sending party wants to keep sending some segment or some data to the receiving party without a way to know that the receiving party actually receives those information, then there may be a lot of information loss. So this is why it's important for the sending party to have a way to know that the receiving party actually got the information. Think of it as a delivery message when you send an SMS on your phone. So this is one of the functions that is found at the transport layer. The next one is sequencing. So having know that the receiving party is there and the receiving party is processing the information that is being sent by the sending party, there's also a need for the information to get to the receiving party in the order and manner in which they have been sent. For example, if the sending party is sending go to bed, for example, it should arrive at the receiving party as go to bed, not as bed to go. So it has to arrive in the sequence, in the exact sequence that the information has been sent by the sender. The receiver has to receive it in such exact sequence. And that is what sequencing function of the transport layer does. The third function of the transport layer is the flow control. So flow control ensures that the sender is not overwhelming the receiver. So it's a way of controlling the amount of information that the sending party is sending to the receiving party in such a way that it matches what the receiving party can process at a point in time. For example, the sending party is a quantum machine that has high spec, and the receiving party is a Pentium 4 machine, a Pentium 4 computer, just for example. So flow control ensures that the information that the sending party is sending, even if the sending party is sending at the rate, at its own rate, the receiving party is able to process them and no information is lost. So it's a way to govern the flow of data, the amount of data that the sending party is sending to the receiving party. That is what flow control does. And flow control happens in transport layer in 2 or 3 ways. So it can happen by buffering, in fact, in 3 ways. It can happen by windowing, and it can happen by congestion avoidance. Congestion avoidance. So buffering means that the sending party is sending information at its own rate, at a very high rate, but the receiving party can only receive the information or can only process the information at a lesser rate. So what buffering does is create a kind of special memory space on the receiving party or on the communication network. And once the receiving party is processing a certain information at a point in time, extra information or additional information gets stored in the buffer. So the additional information gets stored in the buffer. So once the receiving party is done processing the current information, it picks the next information from the buffer. Then the transport layer, the flow control function of the transport layer fills the buffer again with additional information in such a way that no information will be lost. Because if the sending party is sending information at the rate of 20 megabytes per second, for example, and the receiving party only have the capability to process 5 megabytes per second, so what happens is about 15 megabytes of information will be lost every second. But with buffering, so the sending party is sending 20 megabytes per second, and the receiving party can only process 5 megabytes per second. So what happens is a buffer will be created, and that buffer will store 15 megabytes per second. So once the receiving party is done processing the 5 megabytes per second, it picks another 5 megabytes per second from the buffer. This is the buffer. So it picks another 5 megabytes per second from the buffer, leaving about 10 megabytes per second in the buffer. So what happens is the sending party sends another 20 megabytes and the size of the buffer increases. So this is a way that the transport layer uses to avoid a lot of overwhelming of information between the sender and the receiver. And this is how the buffering function of the transport layer works. Another characteristics you find at the transport layer is windowing. Windowing ensures that information is sent according to a particular window size. That is why it is called windowing or window size. So what happens is the transport layer establishes a communication window. It establishes a communication window and gives a size to that communication window. Let's say in this case, the window size is 100 megabytes, not per second, 100 megabytes. So what it means is this flow, the connection between the sender and the receiver, the size of the pipe is 100 megabytes. And what it means is even if the sender has the capability to send 1000 megabytes at a point in time, only 100 megabytes can pass through the communication channel, and only 100 megabytes will pass through to the receiver. So it sets the limit of the maximum amount of information that can pass through between the sender and the receiver. All of this is in a bid for the transport layer to avoid overwhelming of information or loss of information between the sender and the receiver. Don't forget, there are 3 functions that are found at the transport layer. The first is acknowledgement, we've explained. The second is sequencing, and the third is flow control. So we're explaining flow control by also breaking down flow control into three. So there are three methods of flow control that happens at the transport layer. That's buffering, windowing, and the third one is congestion avoidance. So we've explained buffering, we've explained windowing. Let's quickly have a brief explanation of how congestion avoidance happens. Congestion avoidance is what it seems like, CA. So it means that the sender has sent a batch of data to the receiver, and the receiver is currently processing this batch. So it's processing batch 1. So as long as it's processing batch 1, it is considered that the receiver is busy. So what it means is if the sender tries to send another message to the receiver, the communication channel is going to reject that message. It's going to, by sending a flag, by sending a special kind of message to the sender to say that the receiver is busy. So that it might say send any message. It can say things like system busy or user busy or receiver busy. This is what happens when somebody does not activate a call waiting feature and is currently receiving a call, but another call is coming in. So you get messages such as user busy or number busy, all sort of messages like that. So those kind of messages are congestion avoidance messages. They are called congestion avoidance flag to avoid the sender from overwhelming the resources of the receiver. So these are the functions you find at the transport layer. So all of this happens at the transport layer of both the sender and the receiver. You can see that acknowledgement cannot happen alone on the sender side. It has to happen also on the receiver side. Sequencing will not happen alone on the sender side. It also has to happen on the receiver side, because the sequence, there is going to be a sequence number that is attached by the sender, and the receiver has to confirm that sequence number. Flow control also does not happen only on the sender side. It also has to be processed or happen on the receiver side. So these are the things that happen at the transport layer. And at the transport layer, all of this happens, and the transport layer is going to add an header to the data stream that is coming from the session layer. So the transport layer is going to add a kind of header. So let's call this, it is not just a single header, there might be several headers. It can add an acknowledgement number, it might add a sequence ID or a checksum, and it might add a sequence ID. So all of these forms the header that the transport layer adds to the data, and the whole of this, both the header and the data, now becomes segments. So all of those, it's correct to say that all of those functions happen at the transport layer in order to convert the data to segments. So what happens next is the transport layer, the data is still passing from the sender to the receiver. So the transport layer passes the data now to the network layer. So what happens at the network layer? Even though the data, the sender now acknowledges, the receiver now acknowledges the sender, there's a sequence number attached, the flow of the communication has been governed, has been restricted by the functions at the transport layer. Yet, the information does not know where it's going to. There is no address added to the information yet. It doesn't know. All of this is still happening at the communication link, but the specific address where the information is going to has not been added to the information. And that's what happens. That means the transport layer passes segments down to the network layer. So the network layer takes this segment. So this is a segment, and the network layer adds a logical address of where it's going. You can call this an IP address or a logical address of where the segment is going. And when the logical address has been added, to the segment, then the segment becomes a packet. So the network layer is layer 3, and this is where routing functions happen. Routing functions, this is where it happens. So what are the various routing functions? The functions you find at the router, at the routing level. So is packet filtering. This is where you can filter the packet to say that, okay, this packet should go, because this is now packet that happens at the network layer. So when you add logical address to it, is a way of saying that, okay, this segment should go here, this should not go there. So that is what the featuring does. Then this is where, apart from that, there's also path selection. It also happens at the network layer. Path selection is to say that, okay, this segment should go through this particular route and this should go through another route. We are going to explain all of this. It's just that this is not a networking course. This is a network aspect of the course that you need to understand cybersecurity. But in my network series course, I'm really going to explain the whole of this and how they work. So all routing functions happens at the network layer, and it makes sense to say that an example of a device you find at network layer is the router, because routers perform routing functions such as packet filtering, path selection, and or every other IP addressing and every other routing functions that you might think of. So now our segment has been converted to a packet by having a logical address or an IP address, which is a specific location where it is going to meet the receiver. The IP address can be 1.1.1.1, for example, to meet the receiver. So this IP address is the IP address of the network layer of the receiver side. But then it knows the address of where the segment is going. But so the network layer is going to send out the packet, and it's going to send out the packet to the next layer, to the next lower layer, which is the data link layer. Yes, we know where our packet is going, but we don't know who the packet is going to meet. So this is where that happens. The data link layer takes the packet and it adds MAC addressing of the receiver. So this is a packet and it adds MAC address of the receiver. See MAC address of the receiver as the DNA of the receiver. We know where the information is going, but yet we don't know who the information is going to meet. So the packet that already has physical addressing or MAC addressing is now called a frame. So the data link layer converts the packet into a frame by adding the specific address of the person who the packet is going to meet by adding it to the packet. So framing happens here. And there are other functions that happens at data link layer, but the major function is framing. The packet is add as a MAC address and is converted to frame. So again, I'm clearing the canvas so that we can have enough space to work again. Don't still forget that we're still dealing with the sending side and also the receiving side. Now we have the frame at the data link layer of the sender. The frame is a packet that is coming from the network layer, which has a MAC address header so that it can know the specific device it's going to meet. Now, the next thing is the frame passes from the data link layer to the physical layer. Physical layer is where you have your cables, your communication medium. This is where you find your communication media generally. So it might be cables, it might be radio connection, it might be fiber connection, it might be wireless connection, it can even be a Bluetooth connection, as the case may be. So at the physical layer, the only thing that passes through the physical layer is zeros and ones, bits. 0, 1, 0, 1, 0, 1, 0, 1, which means that once the data passes from the data link layer to the physical layer, it's converted into bits. So conversion to bits happen at the physical layer because only bits can pass through wires. So these are now the functions of the OSI layer, the different layers of the OSI from the sender side. Let's see what happens at the receiver side. So at the receiver side, this is where, so we are now talking about the receiver. The receiver receives the bits, the zeros and ones from the sender, 0, 1, 0, 1, 0, 1 bits. So this bit is coming in from the sender. So what's the next thing that the receiver should do? The receiver will reassemble these bits so that it can become a frame and passes the frame to the data link layer. When it gets to the data link layer, the frame is packets plus the MAC address of the receiver, or the physical address of the receiver. Now, when it gets to the receiver, it has gotten to the MAC address where it is sent to. So this MAC address will be stripped off because it's now at the device where it's going to. Then the data link layer will now send the packet to the network layer. So when it gets to the network layer, so this is what is coming to the network layer is a packet. But don't forget that the packet is a segment plus IP address or logical addressing. So let's just use IP address for example. So when it gets to the network layer is where IP addressing happens. And what it means is from the sender side, the IP address that was added to the segment is the IP address of the receiver. And now is at the receiver's end. So the IP address also is stripped off. Then we have the segment. The network layer does not understand segment, so it immediately passes it to the transport layer. So it passes the segment to the transport layer. So all the functions that happens at the transport layer, sequencing, sequencing, acknowledgements, congestion avoidance, all of those will still happen at this transport layer. And after all of those processing happens, for example, at the transport layer is going to check if the sequence number matches what the sender has sent to ensure that it's the original message that was received. The transport layer is going to acknowledge the communication to say, now I have received the information back to the sender. So all of those functions that happen at the sending side will also happen at the receiving side for the transport layer. Then once the transport layer receives the segment, so the transport layer also will strip off all of those functions, all of those sequence number, acknowledgement number that was put there by the sender when it gets to the receiver. So it strips all of this off, then it passes the data. What now goes to the upper layer is the data. So the data goes to the upper layer. At the upper layer, we have the application layer, we have the presentation layer, and we have the session layer. So when the data gets to layer 5, which is the session layer, because this is the layer immediately above the transport layer. So the next thing that happens is the communication session that was established by the sending side, by the session layer of the sender, is going to be torn down at the session layer of the receiver. So now the communication will be terminated. So it's correct to say that the session layer is responsible for establishing the communication session and also tearing down the communication session. Why? Because it establishes the communication session at the sending side and it tears it down at the receiving side. So this is what I meant when I said that we are going to be combining the functions from both the sending side and the receiving side to form an holistic function of each layer of the OSI model. So we can say that the data link layer is responsible for conversion of the packet into frame and also for reassembling of bits back into frame on the receiving side. So this is how we are going to be able to form the various functions of the OSI model. Let's continue. So the session layer tears down the session and passes the data to the presentation layer. So all the formatting that happened at the sending side, presentation layer is responsible for data formatting. So all those formatting will still happen at the presentation side of the receiver. And again, if there is any encryption that has happened at the sending side, this is where the encryption takes place. So if there's any compression that has happened at the sending side, because this is where the compression takes place. So wherever formatting that has been applied to the data at the sender side, then at the presentation layer of the sender side will be removed by the presentation layer of the receiver side. And the presentation layer of the receiver side will now present the data to the application layer. So that's another function. So in addition to all the data formatting function that the presentation layer does at the sending side, it's also correct to say that it presents the data to the application layer. That will be on the receiving side. So when you are thinking about the function, think of it on the sender side and also on the receiving side and combine the two. That will tell you the function of each layer of the OSI. So the presentation layer presents the data to the application layer. And don't forget, the application layer is the user interface where the user interacts with the rest of the network. So this is a brief explanation of the functions that you find at each layer of the website. So let's quickly run through the functions as a summary. So as a summary, the application layer provides a user interface. We spoke about this. So it provides a user interface. And it provides interaction between the user and the application. This is where that interaction takes place. Then the presentation layer, it presents data. Where does it present data? At the receiver side. It has to present the data back to the application layer of the receiver. So it presents data, and also it handles data formatting such as encryption, decryption, compression, decompression, any form of formatting you can think of that can be applied to the data happens at the presentation layer. And the reverse of that happens at the presentation layer of the receiver side. The session layer maintains the extension between data of separation application. What that means is it creates, terminates, and manages communication session, because every communication is a session. When you go to a web browser and you type a particular web address, you have to establish a communication session with the server. So, and that is what the session layer does. So the session layer creates this communication session at the beginning of the communication. It terminates it when the communication gets to the receiver, and it manages what happens at that session. So it means that the security of the session also is part of the communication session. Then the transport layer provides end-to-end connection. We've seen that end-to-end connection in the sense that all the functions that happens at the transport layer, sequencing, congestion avoidance, it helps to ensure that there is end-to-end connection. It means that if there's a problem at the transport layer, because don't forget that we spoke about the transport layer being the bridge between the lower layer, layer 321, and the upper layer, layer 567 of the OSI model. So if something happens to the transport layer, there will simply not be any communication between the sender and the receiver. So it provides end-to-end connection, and it manages things like delivery, checking of error of packets, and all of that. So all of those happens at the transport layer. At the network layer, we said this is where logical addressing happens. This is where you add an IP address to the segment to tell the segment where it is going to, of course, and this is when it becomes a packet. All other routing functions, such as path determination, which is path selection, which path or which route should, path means route, of course. So which route, so this is where you find routing function, should the packet go through, happens at the network layer. And the network layer will determine which route is less expensive, is shortest. For example, if a packet has to pass from one router to another router, and let's say this is the third router. So this is ABC, part A, part B, part C. So if this packet is coming from location 1 to location 2, it's shorter for the network layer to pass it through communication link A directly, because it's going from 1 to 2, than bringing it to B, then from B taking it to C, and now arriving at 2, because this other route is longer. So those are the kind of logic that happen at the network layer. It determines the path, the communication path that the communication is going to take. The data link layer, this is where media access is provided. This is where physical addressing happens. MAC address, this is where MAC address is added to the packet. So this is where MAC address. MAC address is also called physical address. So this is where it's added to the packet. And also, this is where data are packed into frame, and this is where the framing happens. At the physical layer, this is where conversion of the frame into digital data, which is bits, zeros and ones. This is where it happens. Zeros and ones. So this is where the entire packet communication that is coming is converted into bits, zeros and ones, so that it can be sent over the communication medium. It can be sent over wires, it can be sent over wireless medium. And this is what specifically moves data between the sending host and the receiving host. This is where the movement happens. So, and this is a physical medium where data is transmitted as it is on the OSI model. On this note, I believe you have a thorough understanding of how to form the various functions that happens at each layer of the OSI model. Then in the next videos, in order to keep the length of the video optimal, at the next video, we are going to be looking at what kind of protocols do you find at each layer of the OSI and how do you apply security measures? What kind of attacks can happen at each layer of the OSI model? Until then, click the like button, click the subscribe button and the notification button. Thank you for taking time to watch the video.